Alrighty, lastly, video number 3, we're going to start looking at counting principle, fundamental counting principle in lesson 5 on page 757. For this lesson, you could possibly need a calculator, so you can have that out at this point. And so let's get going here on this first introduction page. So it talks about Tyler that wants to take a class at the community center. The table shows the class options he is considering. All of the classes are offered only on Monday and Tuesday. So number 1, according to the table, how many classes is he considering? So there's drawing, martial arts, and dance. So he would be considering 3 classes. And then how many days are the classes offered? Well, they're just offered on Monday and Tuesday according to the table there. So just 2 days. So in number 3, complete the tree diagram to find the number of different class and day outcomes. And so we just got done doing this in lesson 3. So you'll notice, right, here's drawing. This is the trunk of our tree here starting off. And so one of the possibilities is the drawing class, which is offered on Monday or Tuesday. And so you would have an outcome of taking drawing on Monday or taking drawing on Tuesday. Martial arts is the next class that's offered. So notice we have to fill in the blanks here. So martial arts was also offered on Monday, and I'm just going to abbreviate here, and Tuesday. Those are the 2 days. So now we're starting to use those branches, the next event, the days that it's offered. And so he could take martial arts on Monday. That's one possible outcome. He could take martial arts on Tuesday. So we're going to write that. Martial arts Tuesday. And I'll abbreviate there too. Okay. Lastly, the last class is dance. So we're going to fill that into this tree diagram. Once you put dance in, that satisfies the whole trunk of the tree, the first set of options for the class. And then we take these branches for the days of the week it's offered. So dance is also offered on Monday and Tuesday here. So we're filling that in. So he could take dance on Monday, and he could also take dance on Tuesday. Right? So we just got done practicing drawing these tree diagrams over the last few days. So this should look familiar to you. Now, number 4, find the product of the 2 numbers you found in exercises 1 and 2. Product. How does the number of outcomes compare to the product? So when we find that outcome of those 2 numbers in exercises 1 and 2, and we find the product of them, product means to multiply. So we're going to take the 3 classes that are offered times the 2 days of the week that they're offered. So we're going to do 3 times 2 and see that there are 6 outcomes. So how does that number of outcomes compare to the product? Now look at the outcomes in the tree diagram. When we drew the tree diagram, we noticed in the sample space here, 1, 2, 3, 4, 5, 6. This also has 6 outcomes. So your tree diagram and us finding the product of that is 6 outcomes. So they are the same. So you're going to see when we do counting principle, it's actually the easier way to find the number of outcomes. Counting principle will allow you to multiply all the possible events, outcomes that you can get, again, using multiplication instead of drawing the tree diagram. So it's just another easier option to do it. You use it definitely more when you have large amount of outcomes where a tree diagram is just almost impossible to draw because it'll be too big. So we're going to look at that definition. Okay, so if we go to the next page on 758, it says right here at the top, you can use multiplication instead of making a tree diagram to find the number of possible outcomes in a sample space. And again, this is called the fundamental counting principle. So you're going to see here in example number 1, you're going to see both. You're going to see the tree diagram, and you're also going to see the counting principle. So it says find the total number of outcomes when a coin is tossed and a number cube is rolled. And so we know if we use the counting principle here that a coin has two possible outcomes, right? Heads or tails. So that's why you see two there for the coin, two outcomes. A number cube has six possible outcomes, right? So on a die, you know there are six sides. We've talked about that quite a bit so far in the last two lessons. And so times six, two outcomes on the coin, six outcomes on the number cube. Multiply the possible outcomes of each event. 2 times 6, 12. You should have 12 possible outcomes. And so here's a different way to prove it. Here's the tree diagram. So in the tree diagram, you take the coin and you put down first for the trunk of the tree, heads and tails. Those are your first two outcomes that you can get. Then you start drawing your branches, and your branches then are your next event, which is the number cube. And since there are six sides on a number cube, you're drawing six branches out from heads and from tails. Because if you look at the sample space, if you flip heads and get a 1 on the number cube, that's a possible outcome. Heads and then a 2, heads and then a 3, and so on. You're going to see the same thing with tails, right? So tails on the coin comes up, and then a 1, tails, and then a 2, and so on. If you were to count this entire sample space from the tree diagram, you are also going to see 12 outcomes. So when you look at the two right now, the tree diagram is fairly big. I mean, you had to draw 6 branches here. And so as the tree diagrams get larger, too big, this counting principle just makes it quicker and easier to figure out your outcomes. So let's take a look at the got it. Let's try one. So it says find the total number of outcomes when choosing from bike helmets that come in 3 colors and 2 styles. Now notice in this problem, it doesn't tell you the 3 colors. You don't know what they are, and you don't know the 2 styles. So really, if you have only this information, drawing a tree diagram is not going to help you, right? Because you wouldn't know necessarily what the trunk of the tree is, because you would start with the colors, and you don't know the 2 styles, so the branches, right? You just wouldn't be able to complete it. And so this is another way when you don't have enough information that you can use that counting principle. So if you know there are 3 colors of the helmets and 2 different styles of the helmets, 3 times 2, you would have 6 possible outcomes, even though you're not given a ton of information, okay? Let's keep going. Let's see, I think we're going to take a look at, let's look at example number 3 here. So on the next page on 759, so this story here says find the number of different jeans available at the jeans shop. Then find the probability of randomly selecting a size 32 by 34 slim fit. Is it likely or unlikely that the jeans would be chosen? So if you look at this table, you have quite a bit of information. And so it almost seems that if you were to draw the tree diagram, it might start to get a little too big, which is fine. Then let's use the counting principle. Let's make it easier on yourself. Look at the amount of waist size that you can get. So you can get a 30, 32, 34, 36, 38 in those jeans. There are 5 different waist sizes here. So you can put 5 times, there are 3 different lengths available, 30, 32, 34, times 3. And then there are 3 different styles, the slim fit, boot cut, and loose fit, times 3. So you're multiplying the waist size, how many are available, 5. The length in the jeans, there's 3 of them, times 3. And the 3 different styles that are available as well, times 3 again. When you multiply those 3 values together, you would have 45 total outcomes that you could choose at the jeans shop. So it did say to you, so once you find the number of outcomes, it says, what is the probability of randomly selecting a 32 by 34 slim fit? Well, if there's 45 different types of jeans to choose from, out of the 45 possible outcomes, there's only going to be one like that, right? A 32, a 34 slim fit. there's only going to be one possibility. And so you're going to see here, finding that probability would be 1 out of the 45 total genes to choose from. And if you divide that out, it's only about 2% chance that you're going to randomly select a 32 by 34 slim fit. That's unlikely, right? So if we just think back about the number line earlier in the chapter, and we think about where that falls in that number line, 2%, that's a very unlikely event. That's unlikely you're going to randomly select that particular pair of genes. Okay, so let's take a look at the got it here, letter B. 2 number cubes are rolled. What is the probability that the sum of the numbers on the cubes is 12? And how likely is it that that sum would be 12? So I want to give you an idea here of what this is going to look like. Now, 2 number cubes. I want you to think about a tree diagram for a minute. You know on number cubes that you have 6 sides on each one, right? So if you think about the first number cube, you would have for the trunk of your tree 1, 2, 3, 4, 5, 6. Okay. Here's the trunk of your tree. Here's the first number cube. You have these 6 possibilities of landing on that number cube, any of these numbers. So now you roll a second number cube, and that second number cube still has 6. So that would mean here you would have to draw from each one 6 branches. Because again, you have 6 possibilities. So this is where, again, notice how things are starting to run together and there's just not a ton of space, right? And so as the tree diagrams get wider, longer, bigger, more outcomes are likely. It becomes really hard to work on those and figure out your outcomes sometimes. It just becomes, it's not hard, but it'd be easier to do something like the counting principle instead. So let's do that. 2 number cubes. First number cube, you know there's 6 possibilities times the second number cube, 6 possibilities. So if you were to do that, 6 times 6, that means you have 36 possible outcomes when you roll 2 number cubes. So when it asks you what the probability is that the sum of the numbers on the cube is 12, think about that. What 2 numbers could you add together to get a total sum of 12? Well, can't you only, on the first number cube, take that 6, and on the second number cube, also take the 6. 6 plus 6 is 12. That's the only possibility that you're going to get a sum of 12. There's no other possibilities. 4 plus 8 is 12, but 8's not on a number cube, right? 10 plus 2 is 12, but 10's not on a number cube. This is it. This is the only probability you would have. So as far as what that probability looks like, it's 1 out of 36. So when you roll those 2 number cubes, there's the probability of getting 12 only once out of 36 possibilities. And so if you were to actually even divide that out on your calculator, just to look at that as a percent, 1 divided by 36, that's 3%. So again, that's unlikely. So it's very unlikely that you're going to roll those numbers to get the sum of 12 when you roll 2 number cubes. Okay. So let's go to guided practice. And so this is on page 760. So let's take a look at a couple of these together, and then I'm going to have you try some today, and then we'll end our hour here in just a minute. So number 1 on guided practice says, use the fundamental counting principle to find the number of outcomes from tossing a quarter, a dime, and a nickel. So if we think about a quarter, we know there's heads and tails, right? So there's 2 possibilities on a quarter times, talk about a dime, heads and tails again, 2 possibilities there. Sorry about my messy handwriting. And then the nickel. Okay. So also heads and tails, so times 2. So you have 2 times 2 times 2, which is going to give you 8 total outcomes when you toss a quarter, a dime, and a nickel. 8 outcomes there. Okay, let's try number 2. How many outcomes are possible when rolling a number cube and picking a cube from 4 different colors? So rolling a number cube, you know there's 6 possibilities on a number cube. And then picking a cube from 4 different colors. Well, if you have 4 different colors, we're just going to multiply it by 4. So 6 times 4, you would have 24 outcomes here. Let's do number 3. Find the number of different outfits that can be made from 3 sweaters, 4 blouses, and 6 skirts. Then find the probability of randomly selecting a particular sweater, blouse, skirt outfit. And is the probability of this event likely or unlikely? So let's do counting principle. Let's take the 3 sweaters times the 4 blouses times the 6 skirts. So let's multiply these together. 3 times 4 is 12. 12 times 6, you would have 72 possible outcomes here. And so if you're going to randomly select a particular sweater, blouse, skirt outfit, it's going to happen 1 out of the 72 possible outcomes. And so you can already tell if it's 1 out of 72 that it's going to be very unlikely. So if I divide that out and look at the percentage, it's only 1%. So this is also unlikely to happen. So I'm going to have you try a couple. You're going to look at guided practice on page 761, and you're going to use the counting principle. Don't do any tree diagrams. I want you to focus on understanding with this counting principle that you're going to use multiplication here. So you're going to try number 1. You're going to try number 2. I'm going to have you try number 3 and number 4. So let's stick with those 4 right there. See with using counting principle if you can get those figured out, and then pause the video to do that, and then come back when you're ready and we'll talk about the answers. Okay, let's check. So for number 1, you have 4 different kind of bagels. So realize here in this table, plain blueberry, cinnamon raisin, and garlic. There's 4 of them. So cinnamon raisin is 1 bagel here, not 2. So 4 bagels, cream cheese, plain chive, sun-dried tomato, that is 1 as well. So times 3. 4 times 3, you have 12 outcomes possible. Number 2, choosing a sandwich here and a side from the table. So you have 5 different sandwiches and 4 different sides. So you have 20 possible outcomes or 20 possible choices on a sandwich and a side there. Number 3, picking a month of the year and a day of the week. So there's 12 months in a year, 7 days in a week. And so 12 times 7, that's a possible of 84 outcomes. Last one, number 4, choosing comedy, horror, or action movie. So that's 3, each shown in 4 different theaters, times 4. There's 12 possible outcomes there. Okay, so we're going to stop here for today. And if you do still have some time, like I said, I just put 1 counting principle practice in Google Classroom for 7th grade math. So you can head there next. And then on Monday, we will practice a little bit more with counting principle. And then on Tuesday, we'll do the quick check with tree diagrams and counting principle. So have a wonderful weekend, and we'll see you back on Monday.